Okay guys, so after watching videos all the time, I want to start out today's different. So in just a second, you're gonna stand up and then I want you to stretch. So, give me a couple of these, get a good stretch, and then just shake it off. And then we'll get started today, okay? Because I know it gets old having to just sit at a computer all the time. So do that and then come back to the video. I'll give you a second, pause it. Okay, so now that you're back, we're going to be making some foldables today. So by now you probably have already been given a paper that's already folded in half with lines on the front. Okay, if you want to go ahead and continue those lines on the inside so that it opens like a little book, you can. But they mainly need to be on the front. If you're at home and you're watching this, just take you a piece of paper, fold it in half hamburger style, and then draw two lines, splitting it into thirds. Okay, that's what we've done. So if you're in my class and watching this, you can go ahead and go grab some glue. You won't need it till you are done writing on it, but you will need a glue stick. And if I'm having you share, we'll talk about that, but I will have already told you what to do on that. But it's going to be up here at the front in my chair. Come get you a glue stick. Okay, so what we're going to do, the first thing on this very top section to where it opens like a book, okay, how you would read a normal book, you're going to write the word really big, exponents, okay? So hold on, I'll write that and show you. We're not going to be writing anything else in that section, so it's okay to write it big. Exponents, E-X-P-O-N-E-N-T-S, exponents. Okay, once you get that, you're going to open it up, and in this top little section here, you're going to write a definition, an example, and then a problem I want you to try. So it's on the board over here. Let's see if I can get it to turn. It says exponent tells how many times a number is used as a factor. Okay, then you're going to write this. It says 5 to the n power equals 5 times 5 times 5, ... The reason for that is because 5 to the n power, we don't know what n is. It just means some number. So ... means however many times till you get to n. Then you're going to write this problem down. 5 times r times s times s times s times s equals, and then I want you to write what that would be simplified. Okay, so for example, if I had 5 to the third power, that would mean 5 times 5 times 5. Well, this is just backwards. Okay, I want you to try it. That's all you're going to put in that top little section. So let me do this. I'll hold this here so it'll stay so you can pause it and get that written down. So pause it right there and write it down. Okay, so then after that, what we're going to do, so it'll look like this. That's all you're going to write in that top little section. Now, you're going to take your paper, whatever page you're on in your composition book, okay, make sure you put 4-1 at the top. You're going to glue it on that whole page. Okay, glue it to where you can still open it. Okay, then turn the page to start your notes for the video today. All right, once you get that glued, go put your glue back up at the front, and then we're going to be taking notes on the rest of the video. Okay, now for the note part of our lesson, this is 4-1, powers and exponents. So we just did our exponents on the foldable, so now flip your page and we're going to look at taking notes over the lesson now. So example 1 says write each expression using exponents. So we're not actually solving, okay? If you notice, example C is the one you wrote down in your little foldable. So if you didn't get it right, now you'll be able to. So example A, we have -8 times -8 times -8. So we are not solving for anything right now. We're just rewriting it using an exponent. So the number that is being multiplied is your base number, okay? The number, big number. Then how many times is your factor? So 1, 2, 3. It's there 3 times. So that's your little number. So that would be -8 to the third power. So then on B, if you notice, we have a lot going on. We have k plus 2 in parentheses being multiplied over and over. So again, you just take what's being multiplied and write it down. Make sure you keep your parentheses on this because we have two things that are being raised to the exponent, not just one. And it's being multiplied 4 times. So k plus 2 in parentheses to the 4th power is how you would write that. Then on C, we have 5 times r times r times s times s times s times s. So you just take each number that's being multiplied, each different thing that's being multiplied. So we have a 5 being multiplied, we have an r being multiplied, and we have an s being multiplied. Now you can go back into your exponents. There's only one 5, so we don't put 1 as an exponent. We just know it's there one time. R is there 2 times, so I have to the 2nd power. And s is there 4 times, so s to the 4th power. So it would be 5r squared s to the 4th power, like right here. Okay, and since they're just side by side, that still means they're being multiplied. The only other thing we need to talk about is if you have a number to the 0 power. I think we already talked about that, but just in case we didn't, 5 to the 0 power, anything to the 0 power means that 5 is there 0 times. That cancels, and it just equals 1. Always, no matter what the number is, if it is to the 0 power, it will always equal 1. All right, so what I want you to do, you're going to go and try all 4 of these because these are not super difficult since you're not actually solving for anything. You're just going to write 1a, 1b, 1c, and 1d using exponents. Example 1 in all 4 of these, you're not solving anything. You're just rewriting it using an exponent. So on 1a, you take what's being multiplied, and your exponent is just how many times, and it's there 3 times. So 1/2 to the 3rd power. On 1b, we have x being multiplied, and it's being multiplied 5 times. So x to the 5th power. On C, we have C minus D being multiplied over and over. So we keep it C minus D in parentheses because it's all of that being multiplied 2 times. And then D, this one, never mind, we just talked about that. Okay, so this one, we have a 9 being multiplied, an F being multiplied, and a G. So I'm going to go back and look. 9 is just there 1 time, so it doesn't have an exponent. F is there 4 times. G is there once. So it is 9 f to the 4th power g, because that means 9 times f to the 4th power times g. So now on example 3, there's that fancy word again, evaluate. It says x squared, or x to the 2nd power, plus y cubed, or y to the 3rd power. So evaluate x squared plus y cubed if x equals 6 and y equals -2. The first thing we always do is rewrite it. So right here, x squared, x is 6, so I have 6 squared plus y to the 3rd power. So it means all of y is raised to the 3rd power. So when it's a -2, we have to put it in parentheses, because look at this little sticky note over here that says, watch out. This is the big issue everyone does with negatives. If the whole number, the negative, is being raised to the exponent, it needs to be in parentheses, because they show us right here. -3 in parentheses squared is not the same thing as -3 squared. Because when it's in the parentheses, that means -3 times -3, which is +9. If it's -3 squared with no parentheses, it almost means that that negative is outside the parentheses. So you would do 3 squared first, 3 times 3, which is 9, then times that negative. They showed it being like a -1. So that comes out to -9. So the parentheses with the negative number and exponents are very important. So back over here to the problem. 6 squared means 6 times 6, which is 36, plus -2 to the 3rd power. So that means -2 times -2 times -2, like over here. -2 times -2 is +4. Then you have 4 times -2, which is -8. So instead of saying plus -8, that's the same thing as just saying -8. 36 minus 8 is 28. Okay, so I want you to take your time and try this. You're going to do 3A, 3B, and 3C, and this will be the last examples we do today. So take your time. They tell us evaluate each expression if A equals 5, B equals -2, and C equals 3/4. If you end up getting a fraction on any of them, keep it a fraction. Don't change your answers to decimals. Okay, on problems 3A, 3B, and 3C, we were having to actually solve exponents. So on 3A, we have 10 plus B squared, and they told us B equals -2. So we rewrite it. So when you have a negative that's squared, so that means -2 times -2, 2 times. -2 times -2 is +4. So I have 10 plus 4, and all that, it came out to just 14. So then on 3B, A plus B is in the parentheses, so A is 5, B is -2, all to the third power. So you do what's in parentheses first, parentheses then exponents, your PEMDAS rules. 5 plus -2, you're adding with the positive and the negative, which means you subtract and keep the sign of the larger number. That comes out to 3. 3 to the third power means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Right, on 3C, we have 2 minus C squared. C is 3/4 squared. So that means 3/4 times 3/4. 3 times 3 is 9. 4 times 4 is 16. So 2 minus 9/16. Okay, on that, we first have to get a common denominator. So 2 is a whole number, so it's over 1. So 1 and 16, we're going to make the denominator 16, because then all I have to do is multiply this side by 16. 2 times 16 is 32/16, because 32 divided by 16 still equals 2. We didn't change the value. Minus 9/16. Now we can do 32 minus 9. Well, 32 minus 2 is 30, minus 7 more is 23/16. Now we can simplify. Let me grab my calculator to check my work. So we have 23 divided by 16. It comes out to a decimal, so we know it goes in one whole time. And if we subtract, we get 7 left. So 7 out of 16. So 1 and 7/16. C was kind of difficult, but that's okay.